To solve for mesh currents. Okay, so this one, it's weird the way it's given. No, they're going in the same direction. But you'll notice that this one is actually a super mesh. And the reason why it's a super mesh is because the branch that they share has just a current source. So the super node was when you had a voltage source, you had your node, and then you had a voltage source, and then you had your other node. That makes a super node. And when you have a mesh, but what's between the meshes is just a current source, that's a super mesh. And so just like on the last problem, we had our super node equation, we're going to have our super mesh equation, which is that I1 minus I2 equals 2. And that's because the current going down this middle branch right here is I1 going in this direction and I2 going in this direction. So it's I1 minus I2, and it has to equal that current source. And then our mesh equation, because it's a super mesh, I can just write one equation going around the outside of everything, will be minus 10 from my voltage source plus 5I1 plus J5I2 plus 10I2 equals 0. I'm going to pause and give y'all time after each step to catch my mistakes.
So like it doesn't matter which current source we're trying to solve for first.
It does not. Which one do you want to solve for?
We solve for I1.
Okay, so I1 or I2 equals I1 minus 2. So minus 10 plus 5I1 plus J5 times I1 minus 2 plus 10 times I1 minus 2 equals 0. Minus 10 plus 5I1 plus J5I1 minus J10 plus 10I1 minus 20 equals 0. So then I have 15I1 plus or minus or plus J5I1 yeah, I only have one, yeah. So plus J5I1 minus 30 minus J10 equals 0. So 15I1 plus J5I1 equals 30 plus J10. I'll divide everything by 5 because I can. 3I1 plus J1 equals 6 plus J2. I1, factor that out, and I get 3 plus J equals 6 plus 2J. Am I this lucky? I1 equals 6 plus J2 over 3 plus J notice if I factor a 2 out of that, I get 3 plus j over 3 plus j I1 equals 2.
When do you do the thing where it's like, I1 minus I2, they're going the other direction?
That would be if I didn't have a super mesh. So that would be, and by the way, this makes I2 equal to 0 in this problem. So the question you asked is,
Oh, is that if they share a resistance? On a branch?
mm-hmm.
Okay.
So if I had one that looked like this, that's R1, R2, L1, R3, R4, C1. So this would be, and this is V, I'll just say it's V. So minus V plus R1 I1 plus R2 I1 plus J omega L1 plus R3 times I1 minus I2 equals 0.
Okay.
And then going around on the other side, it would be minus IS plus minus J over omega C1 plus J omega L1 plus R3 times I2 minus I1 plus I2 R4 equals 0.
You're not doing it like separate for each branch. Like you don't do like all of them equals 0 and then all of them equals 0. And there's not two equations.
Well, these are my two equations. I have one for I1 and one for I2.
Oh, okay. So this is a super block.
When it was the super mesh, I combined them into one, yes. Well, I still had two equations, but one of them was just the easy equation that just related the two currents right here.
Okay.
But I didn't do a separate equation for each mesh.
So for the inductor, you have to add the impedance to the things that are in series.
Yes.
And then why is that I1 minus I2? Or is that's I1 minus I2 at the end?
So for this first mesh, the current going down the middle branch is I1 minus I2. And then for the second one, as I'm going around in this direction, it's I2 minus I1. And that's how you do mesh currents. Any other questions?
If you do decide to do like the thing on Sunday, like over Zoom,